Hi everyone, welcome back to our channel. In this session, we are going to discuss about preparation of ethers. In the previous session, we were discussed about the IUPAC nomenclatures of ether, naming of ethers using IUPAC system as well as common naming system. Under preparations of ether, there are two categories that are observed. One is a general method of preparations of ether, and another one is laboratory method of preparations of ethers. Okay. First, we are going to discuss about from dehydration method. This is the general method, and in this case, ethers are prepared from alcohol, okay, using alcohol. When I am using the word, this one, dehydration, I think you are going to somewhere of the alcohol part, because under alcoholic topic or alcohol part, we were discussing the same thing. Alcohols undergo dehydration or dehydration of alcohol. That gives alkene using dehydration or dehydrating agent. Which one is the best dehydrating agent? Yes, concentrated sulfuric acid is the best dehydrating agent. Using concentrated sulfuric acid, the alcohols are dehydrated and it gives alkene. I am using the same thing again. During the preparations of ethers also, I am using the same method. But the difference is temperature or the condition. Okay, let us move on to the part preparations of ether from alcohol using dehydration method. Okay, very, very important thing for your exam point of view. Please do the concentration. How ethers are produced. I am considering the primary alcohol. Okay, I am considering the primary alcohol. The primary alcohols are prepared using or represented like that RCH2OH. But for this case, I am considering one example. Okay, the second member of alcohol. What is the name of the second member of alcohol? Two carbon compounds. Yes, it is ethanol. Okay, ethanol is subjected to dehydration. Okay, CH3 CH2OH. Okay, this is the ethanol. When ethanol is subjected to dehydration, okay, subjected to dehydration method process, what happens? Dehydration. For the dehydration purpose, we should use the dehydrating agent. That one is concentrated sulfuric acid in the both the case. But the difference thing is the temperature. During the dehydration process, suppose we supply more heat. It is more than 443 Kelvin, more than 443 Kelvin. Then the alcohol undergo dehydration and produce corresponding alkene. Corresponding alkene means two carbon compound alkene. CH2 will produce CH2 double bond CH2. What is the name? Ethene. It produces ethene. Ethanol undergo dehydration and produce ethene. The same thing and the same process and the mechanism you are already studied in the last session or the last part under alcohols, properties of alcohols. And then when it produces ether, when small amount of temperature is applied, smaller than or lower than that of 443 Kelvin, around 413 Kelvin. Whenever we supply 13 Kelvin, then the ethanol produces ether. The ether is CH3, CH2, O, CH2, CH3. The diethers, dialkyl ether, corresponding dialkyl ether. What is the alkyl part? Yes, it is eth, ethyl, ethyl ether, diethyl ether is produced. This is the mechanism. This is the process of preparation of ether. Okay, this is the process of preparation of ether. How alcohols are subjected to dehydration using dehydrating agent sulfuric acid around 443 Kelvin that produce corresponding alkyl ether, dialkyl ether. Then the question is arises, oh, is it produce only diethyl or dialkyl ether? Yes, mainly it produce dialkyl ether, and other ethers, the production of other type of ether is little bit difficult because it follows some mechanism and some important things involved under this process. What are the important things? The first thing is temperature. Okay, first thing is temperature. It should be low and around 443 Kelvin. The second thing, the ethanol or alcohols used to produce ether should be a primary. It should be a primary. Okay. Suppose we use secondary or tertiary alcohol for the production of ether, then reaction is not favors. It not favors. Okay. It favors the production of ether. Alkene is produced. Okay. It is a very important thing. Primary alcohols are mainly used for dehydration purpose during the preparation of ethers. Next, when we use the primary alcohol, they undergo dehydration in such a way that it is undergo substitution. What type of substitution we observe? Okay, let us discuss the mechanism of this reaction that give the conclusion what type of mechanism and what type of reactions we observe. When alcohol, step 1, the mechanism, okay, it's not important, but you should know how the reaction take place and all that. The ethanol, when in the first step, alcohol, CH3, CH2, OH, you can consider the same example that I have taken in this reaction. CH3, CH2, OH, it react with acid. What we used in the reaction, sulfuric acid. When acid is react with alcohol, produce. Yes, the first step of this mechanism, you already well known about this mechanism. CH3H, CH2O. In acidic media, alcohol gets protonated. Protonated alcohol is produced. Protonated alcohol is produced in the first step. And the second step 2. Okay, what is this? Yes, it is protonated alcohol. CH3, CH2O. Don't forget to write plus sign. Yes, it is protonated alcohol. When it is heated around 413 Kelvin, when we supply excess of more heat during the reaction, then water molecule evaporated. Water molecule is evaporated. But at the lower temperature, the reaction, different type of reaction dominates. This one dominates the dehydration. How it follows a substitution reaction. another molecule of alcohol. In the reaction media, there is another molecule of alcohol. Alcohol is act as a nucleophile. The oxygen carries excess of electron that act as nucleophile, and it is attacked on the protonated alcohol and it produces CH3. A student correctly observe the reaction CH3, CH2, O, and again positive. CH2 is attacked. CH2, CH3, and one hydrogen remains. Hydrogen of this protonated alcohol and OH of this alcohol is eliminated in the form of water. Dehydration takes place. Yes, it is dehydration. The first thing is also dehydration. It is also dehydration. But the dehydration is not an elimination. In this case, it is not an elimination. It is follows elimination. It is follows substitution reaction. Okay, substitution takes place. Substitution of another molecule of alcohol on protonated alcohol. Protonated alcohol is the reagent and the reactant, and the reagent is alcohol. Reagent is nucleophilic type or nucleophile, therefore it is nucleophilic attack. Nucleophilic attack that leads to formation of nucleophilic substitution reaction, and this one is the primary, hence mainly follows SN2 mechanism. It follows SN2 mechanism. What is the SN2? Bimolecular nucleophilic substitution reaction take place. Yes, it follows bimolecular nucleophilic substitution reaction, SN1 and SN2. The mechanism of both you are already studied in the first topic. That one under haloalkanes and halorines. You are studied what is SN1 and what is SN2 and all that. The SN2 follows SN2 mechanism because of this primary and the nucleophilic protein nucleophile, and it follows SN2 and gives a protonated ether, and in the last step, I think all of you guessed what is the last step of the reaction. Yes, it is CH3, CH2, OCH2, CH2, CH3. Okay, hydrogen, H plus does the same thing. Okay, protonated ether, it loses proton and produce corresponding ether. CH3, CH2, OCH2, CH3. This is the mechanism of the reaction. This is the mechanism of this reaction, and ether is produced in the last step. This is the product. Okay, it follows SN2 and it requires smaller amount of heat. That is the very important thing in this reaction. Please remember, it follows SN2. It should be primary. Alcohol should be primary, and 413 Kelvin is the temperature, needed temperature. Okay, so these are the very important things under this reaction. Okay, one doubt commonly arises when you observe this reaction. What happens when we take secondary and tertiary? What is the things involved? If we take, it is primary, correct? OH attached carbon contains only one carbon. If this carbon contains more number of bulkier group in the place of hydrogen, what happens? Clearly observe. In the place of hydrogen, other alkyl groups are attached. Alkyl groups are electron donor. When these groups donate electron easily, water will evaporate it and produce ET. This substitution reaction is not famous, or substitution reaction is or elimination reaction dominate over the substitution reaction. Okay, this is the reaction mechanism. and the first method of preparation of ethers. Okay, let us move on to the second method of preparation of ethers. The second method is valve method and laboratory preparation of ether, and it is a named reaction. It is known as Williamsons ether synthesis. Williamson ether synthesis. Okay. Williamson ether synthesis. The Williamson ether synthesis is nothing but it is the reaction between alkyl halide, or better to call it as from alkyl halide. Alkyl halides. Alkyl halides RX react with sodium alkoxide and produce corresponding ether. Better to consider R dash. It is O minus Na plus salt of sodium alkoxide, and sodium halide is eliminated in the produced as a byproduct. Alkyl halide. Okay, please take a screenshot after the reaction. Alkyl halide. This one is alkoxide, sodium alkoxide. Okay, it is sodium alkoxide, and ether is produced. This is a very important reaction for your exam point of view, and this reaction is named as Williamson ether synthesis. Williamson ether synthesis is nothing but preparation of ether from alkyl halide using sodium alkoxide. This is a very simple reaction, but it has some important things. What are the important things involved in this reaction? Let us discuss the important things. Williamson ether synthesis, and consider one example of this reaction. The important thing is, in this case, R should be a primary and R dash should be a higher group or higher alkyl group. R should be primary alkyl and R dash should be a higher alkyl group. Then only reaction is favors. Otherwise, the reaction is not favors, and it follows some of the mechanism. Okay, let us discuss the things under Williamson ether synthesis and consider primary alkyl halide because it should be a primary, otherwise it does not follow Williamson ether synthesis or Williamson's mechanism. CH3Cl, this one is methyl chloride plus sodium alkoxide, and consider that R dash should be a, what is the important thing? R dash should be a higher, and consider tertiary CH3, okay, tertiary carbon contains sodium oxide. So this is a 4 carbon compound. This one is sodium tertiary butoxide, third butoxide. Yes, also known as third butoxide, and consider third butoxide and a methyl chloride. This one is the primary and this one is the tertiary. Then only the reaction is favor. Why this reaction? Why this type of reaction is favors, and why we should consider primary and it should be a tertiary? All these things is studied under the mechanism. The process is, it follows, please observe the reaction. In this case there is no negative part, mainly in this case this one, sodium alkoxide contains this oxygen act as a nucleophile, and the nucleophile is attack on the carbon, primary carbon, and is attack on the back side of the primary carbon. Back side of the primary carbon. Back side is opposite direction of the Cl in the three-dimensional view. Carbon at the center and hydrogen, and in the horizontal plane we observe the chlorine. The alkoxide, oxygen of alkoxide is attacked backside, okay, in the mechanism, and it produces or all this tertiary part goes opposite. It is called inversion. Wider inversion is formed. CH3. Okay, this is the ether. What is the name of this ether? Methyl. It is tertiary. Third methyl. Third butoxide. Third butyl methyl ether. Why this third butyl is a bigger part? It's a common name. Please remember, it's a common name. Third butyl is the bigger part and first used during the compounding system, and the smallest part is methyl, and then it is a ether. Okay, third butyl ether is the name of the product. Okay, let's discuss how this reaction take place and what is the mechanism of the reaction. This one acts as a nucleophile. Okay, act as a nucleophile. Nucleophile attack on this methyl chloride on the back side. It's a primary. Just remember, it's a primary. If we use the tertiary or the secondary, then the reaction is not favors. Okay, the same thing we observed in the previous part also. And it is attacked and chlorine is eliminated. And one transition state is formed. During the transition state, carbon contains 3 hydrogen, 1 chlorine, and this one oxygen part, and it's a pentavalent carbon is formed in the transition state, and again chlorine eliminated, and inversion is taken place. Inversion is here observed. This one is the bulkier part of the sodium alkoxide. It goes opposite. Inversion is formed. Okay, like umbrella. Okay, during the wind and the rain season, in a few cases there is a possibility of inversion of the umbrellas. Same type. Okay, umbrella in this side, and after the wind, invert it. So same type is observed. Inversion is take place, and again it is as follows. SN2 mechanism. What type of mechanism observed under Williamson ether synthesis? This SN2. Why? Primary. It's primary, and nucleophiles attack on the primary alkyl halide and produce a ether. Okay. Again, it involves only one step of reaction. Single step of reaction. In this way. Single step reaction, and order is 2. Bimolecular, and nucleophilic substitution. Because of that, it is nucleophilic substitution order toward bimolecular nucleophilic substitution reaction. So, this is a very important thing under Williamson ether synthesis. Again, question arises in your mind. Suppose I am take tertiary and take primary. Okay, before that, please take the screenshot. This is the general formula. This is the example. This one is the one example. Okay, very important part for your exam point of view. You should give the explanation also. What is Williamson ether synthesis? Williamson ether synthesis is nothing but preparation of alkoxide, or the reaction between alkyl halide and sodium alkoxide produce ether. This reaction is named as Williamson ether synthesis. Important thing you should remember is SN2 follows SN2 mechanism. Walden inversion product is formed, and primary alkyl halide is considered, and tertiary sodium alkoxide is considered for this reaction. Okay. Suppose we consider the tertiary alkyl halide CH3 Cl plus CH3 O Na. What happened when this type of reagent is considered? A reaction does not follow SN2. Reaction does not follow SN2. Simultaneously, this one undergo elimination. This one is not involved in the reaction. Nucleophilic attack does not observe. Elimination of sodium chloride. Chloride is take place, and one hydrogen. And hydrogen react with this one and produce CH3OH. Chloride and sodium chloride byproducts are formed. The remaining thing is carbon tertiary. Carbocation is produced, CH3. This one is not produced earlier, and this carbocation classifies electron from any one carbon, and it becomes CH2 and double bond between any one of the carbon. And consider this one, you can consider this one, any one. Okay, and alkene is produced. Okay, please remember these things for your competitive exam. Okay, if we take tertiary alkyl halide and the primary sodium alkoxide, then the reaction is produced alkene. Okay, these are the very important parts under the preparations of ether. Okay, these are the two methods. One is general method of preparation, and the second one is laboratory method of preparations of ether. In this video, we have discussed the preparations of ethers. Okay, both these two are very important for your exam point of view. This one is Williamson ether synthesis is known as named reaction. It is important for your theory as well as competitive exam. And under ether topic, ether part, there is a possibility of asking 2 marks question in your annual exam. That may be a Williamson ether synthesis. In most of the case, Williamson ether synthesis are. Okay, and for your competitive exam also, this part is very important. In the next session or in the next video,